Number 3 from section 1.9. After number 2, this is going to be easy. Let's read the instructions. It says fill in the missing entries in the matrix assuming that the equation holds for all values of the variable. Okay, so they essentially are asking us for the A again, and they give us the image. So let's see if we can figure it out. All right. Well, you might recall, and here's the key idea, that if you have some standard matrix A and you multiply it by column vector X, you can always write that like this. It's always X1 times the first column of matrix A plus X2 times the second column of matrix A, all the way down to Xn times the nth column of matrix A. And we talked about that a few sections ago, so I'm going to try to use that fact in this particular problem. All right. So let's take a look at this thing. If you consider the left-hand side, this is basically our A right there, okay? But the left-hand side, if you wanted to, you could rewrite it like this. It's just x1 times a1 plus x2 times a2 plus x3 times a3, all right? And I'm trying to make it look like this. So it's probably enough for me to just replace that a1 with the 3x1 column matrix consisting of all the coefficients of x1. And I guess that would be 6, 4, and 0, right? And let's do the same thing for the second A2 matrix. If you write all the coefficients of x2, you get -7, 0, and -1. And then x3. Well, look at the coefficients of x3. It looks like 0, -8, and 3. All right, but these are the 3 columns of standard matrix A. So it sounds like A is this. And that's your answer. And if you wanted to double check, you could always just multiply it by x1, x2, x3, and make sure that you get back the original product up here, all right? But it's easy to check. 6x1 minus 7x2, check. 4x1 minus 8x3, check. And third row times that column is -x2 plus 3, x3, check. So there's your matrix.